Bismillahirrahmanirrahim. Assalamu alaikum. Today we will talk about how messaging works in Openstack. First of all, we briefly look at what is the messaging service and what is its role and what are the different functionalities are provided by the messaging service. So let's start with the messaging service. Basically, as the services are decomposed into multiple functionalities, as are the sub-services, so each of the service needs to communicate or interact with each other. This is required for coordination purpose or to implement the basic service, the IT service that needs to be provided. The interaction between these sub-services or the components needs to be achieved reliably, securely, and efficiently, so that the services overall performance remains stable. The service or the functionality that provides the capability to communicate between the different services or establish communications between different services or the sub-services is message exchanging service and is usually called as the messaging service. There are different open source messaging protocols available, such as the AMQP, which is Advanced Message Queuing Protocol, and the MQTT, which is very common and used in IoT applications. And it is basically the message queuing telemetry transport. So these are the two protocols. Both are open source and usually provides the facility to communicate between the different components of a service reliably, securely, and efficiently. The interesting thing is the messaging service or the messaging capability also works as a standalone. I mean, it works on a separate machine and it manages its all functionalities independently. The component that provides the messaging services is usually called the messaging broker. Different components connect with messaging broker, and then messaging broker, based on rules and configurations, provides different kind of message distribution services. In Openstack, the messaging broker service is basically provided by RabbitMQ, and it is efficient and it's secure and it's reliable. We shall discuss in details about the RabbitMQ and how does it work with the Openstack to provide interaction between the different components and different services. So before we discuss that what is the need for the messaging service in Openstack, we need to look at the different requirements that needs to be fulfilled due to the distributed architecture of the Openstack. First of all is the inter-service communications, as we have discussed, that the services are implemented in different machines, and those machines and the services needs to interact with each other. They need to communicate. They need to initiate configurations, some processes. So for this purpose, usually the one service needs to communicate with another service, and this is called the inter-service communications. So Openstack requires the inter-service communications functionality, and this has to be provided by the messaging broker or the messaging service. After this one, there is a event and notification handling, because the services running on different machines may generate different kinds of events and the notifications. So that based on those notifications and events, some certain actions has to be taken place. And also these needs to be sent to certain services or components or the users. So this is the second functionality which is required in Openstack is the event and notification handling, and it should be handled properly. Next to this one is basically decoupling services. This is basically the basic functionality of the messaging broker, that the services should be able to run the services independently and without dependency on any other things. If the capabilities are available, they should be provisioned. Otherwise, it should be running independently. If some of the process is taking too much time, the other processes should be available, and that should be working without any issues or problem. Next one, this one is the scalability and high availability. As we have said, due to the decoupling of services and the running of services on different separate machines, This is one of the requirement for the scalability and availability. So messaging service should make sure that the proper notifications, alarms, and all these things are communicated to the required components. After this one is the handling long-running tasks. As we have discussed that some of the services or some of the resources may take some time to set up them according to the requirements. Or for example, if you take the example of the VM creation process may take time. At the same time, the networks has to be configured and the storage has to be configured. So these tasks may run parallel without any issues. So only a message should be communicated to the server to the particular machine which is providing the storage or compute services. Now we look at the key roles the messaging broker or the messaging service has to provide for the Openstack. If we look at this one, the first of all is the inter-service communications. I mean, of course, the message broker should be able to provide a service that allows the messages to be communicated across the different components or the different servers or the different services. And next to this one is basically the event and notification handling. This is important because the different services or the machines and servers may generate different kinds of events and alarms and those things. So the messaging broker should be able to handle those events to the relevant or the concerned services. Next to this is the services decoupling. I mean, it should allow that basically one of the purpose of the messaging broker is to decouple the services running. I mean, the services which are, for example, if we talk about the compute server or the storage server or any networking server, they should be able to run independently. So just by receiving the message and they should be able, the configuration should be completed, or any resource provisioning should be completed. Next one is the scalability and high availability. This is one of the key roles that messaging broker basically allows, because the messages may be message can be sent asynchronously, and the recipient services or the servers can start configurations without delaying, without depending on the other parts of the services. Another role is the management of the basically the long running tasks. If you see for example, the VM creation process, the networking setup process, or the storage setup process may take some couple of minutes. So sometimes it can take a lot of time if there is a formatting and these things are involved. So the messaging broker should one of the purpose of the messaging broker is that the provisioning processes may keep running without any interference to the original. We have discussed the key roles of the messaging service for the Openstack. We will also have a look at some certain requirements that Openstack has from the messaging broker. One of the first performance requirement is the reliability. I mean, the messages that has been sent by the producer, I mean the machine, the component that initiates the message, should be reliably sent to the destination or the intended component or the service. It should not be lost, and there should be proper acknowledgement also once the message is delivered to the particular service. Next to this one is basically the asynchronous communications. I mean, there should not be any limitation that the provisioning process needs to be asynchronous. This means that these resource provisioning, or the VM creation, storage, and compute instance allocation, these all should be independently handled, and the messages should be sent to them without any particular sequence or synchronously. I mean, synchronously means that one message is sent to a particular component, and then once that process is completed, then if the message broker only generates the message for the next resource after then it will be asynchronous communications. In asynchronous communications, basically the messages to all the required resource or the services should be sent without any issues. This basically improves the responsiveness and the performance of the overall service. And next one is the scalability. This is very important because generally for many of the large OpenStack deployments, there will be thousands of OEM instances or these resources running, and they will generate a lot of messages. So the broker should be able to handle a large number of messages without any performance degradation. And rest is another is the flexible message routing. There should be multiple modes of message delivery. It should allow the filtering and federation and clustering. All these capabilities should be there. This is important from the workflows point of view because different workflows may require the different kinds of the routing or message delivery mechanisms. And after this is the fault tolerance. As we said, the message broker should be able to run in a clustered environment or some kind of federations, so that if one of the message broker is not responding or it has some issues, so another message broker should be able to take those messages and deliver to the right destinations. So these are the five basically the requirements for the message broker for the OpenStack. If we just summarize them, then the reliability, asynchronous communication, scalability, flexible message routing, and fault tolerance, these are important for the performance point of view. Now there are a couple of alternatives available. I mean, there are different candidate implementations for the messaging broker for the OpenStack, which includes the RabbitMQ, QPID, ZeroMQ, and Kafka. Out of them, RabbitMQ is generally the default message broker for the OpenStack deployments, but the QPID and ZeroMQ and Kafka, they are also used in the different environments. Generally, the ZeroMQ is used for small level OpenStack deployments, and Kafka is used for the larger deployments where the message throughput is quite high. However, we need to note that basically the RabbitMQ is generally used as the default message broker, and it has a number of capabilities, and we shall discuss in the upcoming slides. So what is the RabbitMQ? We said that RabbitMQ is used as a default messaging broker for the OpenStack. So there we shall just go through that, how does it works and what are the different components that it has. So first of all, the RabbitMQ is a reliable messaging and streaming server. It is also secure. It supports the AMQP 1.0 to MQTT 5.0. I mean, there are basically different versions available for the MQTT. So it supports up to the MQTT 5.0. It can define how messages from the one publisher to many destinations go. It could be one-to-one, or it could be one-to-many, or we can also define some particular routing strategies, or some filtering. The federation and cluster setup is also supported with the RabbitMQ. If we look at the diagram here, we see that there are generally the users endpoints that generates the messages or notifications. And then there are the other, on the other hand, there are some servers or the services which have already subscribed to the particular messages. So RabbitMQ, what does it do? It basically maintains a queue where the messages keep on arriving, and the messages are sent to the particular recipient or the receiver who is interested in the that particular message. And once the message is received, it sends a acknowledgement to the sender that the message you have sent to the particular destination has been received. If we could talk about the RabbitMQ reliability, it uses basically the acknowledgements. I mean, the messages are acknowledged as we have just discussed, and it's shown in the diagram. And also the messages can be replicated across the clusters, so that in case of if there is any issue with one of the instances of the RabbitMQ service, another service can take over. Another thing is that RabbitMQ is freely available and is open source. You can use it without any cost. Now, before just going into the further details, there are some certain terminologies that are used for the messaging broker or the RabbitMQ. We'll just have a look at them. For example, the producer is basically the one of the endpoint or the user that want to send the message, and similarly the consumer is the one that is interested to receive a particular message. Queues are basically the memory buffers where the messages are stored in the FIFO pattern. I mean, first in, first out, and next to this is the message itself. Message could be anything. It could be a request, it could be a some process initiation request, or it could be an event or a log or something like that one. Channel is the concept that allows basically the one of the receiver to subscribe to the multiple messages. I mean, from coming from different senders or the producers. So eliminates the eliminates the need to establish multiple TCP connections for to the single RabbitMQ to the RabbitMQ server. So next one is the exchange. Basically, it receives the messages from producers and pushes them to the different queues depending on the rules and defined the exchange type. There are different types of the exchanges. For example, the direct or the broadcast type of the exchange, for where the message needs to be sent to the multiple recipients, and there could be also some topic-based exchanges also. We'll just have a look at the exchange types in the coming slides. There's a binding. Binding is basically the link between the exchange and the queue. Routing key is basically a key that exchange looks at the message, that how the messages needs to be handled and how this needs to be delivered to the particular destination. And AMQP, this is a bit we have discussed that this is a queuing protocol, advanced messaging queue protocol, and it is also supported by the RabbitMQ messaging broker. Now, if we look at the architecture of the RabbitMQ, we can see that there are basically the 4 components which are major. One is the first one is the user, or basically the producer, which produces the requests or the messages. And then there is some kind of interface which provides the request initiation basically facility. I mean, the user interacts with that interface. That could be a dashboard or something other user interface. This user interface publishes the messages to the RabbitMQ, and then there is a consumer basically that receives the message. The consumer could be any service, or it could be any server which basically performs some action based on the received message. From the RabbitMQ point of view, there is one functionality that is exchange. This determines that what kind of message it will be, how it will be managed, and how it will be routed or sent to the target destinations. Then the routing basically which basically performs the message routing, that how it has to be carried out. This is basically the link between the exchange to the queue, and it also basically determines the binding of the bindings between the exchange and queues. There could be multiple queues, and once the exchange is determined and the routing is also determined, then the queue is dequeued. I mean, the message is sent to the target destination. So the process of sending message basically starts from the producer, and then it ends at the consumer. The flow of the messages is shown in the diagram. Now, if we look at the different types of the basically the exchanges that determines the delivery type, we just go through this animation. Basically, there are 3 types of exchanges that we have shown here. One is the fan out, which is kind of broadcast, and second is the direct message, direct delivery. This is the direct exchange, and there is a topic. For the fan out exchange type, these different types of the exchanges are then connected to the different queues, which are basically separate queues for which the consumer have already subscribed to receive the messages. So if for the first point of view, in the fan out, when the messages comes and the exchange determines that this is a kind of the fan out message, then it sends to the different queues which are bound to those particular message, or to that particular the exchange type. From those queues, then message is sent to the consumers, or the end users. Basically, in the next to this is the direct type. In direct type, we have a binding key, which basically associates the exchange type to the particular queue, and or some process name where the message is sent to the consumer. Finally, the topic is basically based on the different topic filters. It could be wildcard filters like abc.static or xyz.static. And basically the messages are filtered based on the topics, and then they are sent to the particular queues from where the messages are sent to the consumers. Now, since the Openstack has several components and the several services, basically to provide the overall infrastructure services, in which the messaging service or the messaging broker is one of the service which is utilized by many of the other services. So messaging service basically allows the message exchange between the different services. It can be, this exchange could be between the user to the different components. In Openstack, as we know that there are different components like the scheduler. This is the Nova scheduler, which determines that where the particular resource will be placed in the compute node or the particular compute server. And then Neutron is responsible for the networking. It just configures the networking setup for the particular request. And then Cinder is responsible for the allocation of storage. There could be different type of storage, and those all things are basically managed by the Cinder service. So from this point of view, if we see how the instance is managed in Openstack, first of all, user sends the instance creation request. I mean, user interacts with the dashboard, then it sends the request to the Nova API. As we have already seen in the previous slide, that the from dashboard the request goes to the Nova API. From Nova API, this request is sent to the scheduler, and then scheduler generates a message for the RabbitQ broker. Now, if we take another example, in basically another case where orchestration process takes place, usually the heat service is basically responsible for the orchestration of the resources in the Openstack. So in this one, first of all, user submit a template to the heat engine, to the heat service, and the heat service then send a provision message to the RabbitMQ. From RabbitMQ then sends the message, forwards the message to the Nova service and also to the Neutron service. Both of these one then allocates the required resources and provision them, and then send the confirmation message back to the heat engine. And then heat basically notifies the user that the particular resource has been orchestrated. Take another example in which the message communication, the RabbitMQ is used, you see, for monitoring and alarming purposes. So for this purpose, there is a telemetry which collects the matrices from the different services, and once it collects the messages, then it sends the matrices to the RabbitMQ. From there, RabbitMQ sent the message to alarm service, which basically evaluates the alarms and then inform back the RabbitMQ. And basically it also informs the other resource services like Nova and Neutron. It sends the notification of the particular events or the alarms. And once this is all already done, once this is done, then the final notification to the accelerometer reaches from the RabbitMQ. If we see here, the RabbitMQ sends the matrices to alarm, and then alarm evaluate those messages and send the status back to the accelerometer. There are the cases of the load balancing, in which basically user requests a load balancer via Neutron, and then Neutron sends a message to RabbitMQ to create the load balancer. And then RabbitMQ routes the message to appropriate services, for example Octavia or any other things which are used for the load balancing. And in the fourth step, the load balancing service processes the messages and creates the load balancer. And the fifth step, which is the status message that is sent from the RabbitMQ to the Neutron. This is basically the updates, the status updates which are sent from the message broker to the Neutron service responsible for the networking. Similarly, the notification services also uses the RabbitMQ service to send the notices to different services, and the process usually follows the number of steps where the events occur, and those events are then pushed to the RabbitMQ service, from where the RabbitMQ service then notifies the particular services or the user also. And next to this one is the service coordination. For the service coordination, generally there is a component used, Sahara, which sends the message to the RabbitMQ detailing the request details, and then RabbitMQ routes that job to the worker nodes. This means the Neutron compute server as the sender. From where the worker processes those services processes those messages, and then notifies back to the RabbitMQ service, and then the RabbitMQ service notifies back to the user. In this one also, RabbitMQ plays an important role. Similarly, if you see the data processing also uses the RabbitMQ messaging to inform all the services, and then their status messages are sent back to the user via the messaging broker or the RabbitMQ. As we discussed, that there are multiple versions of the open source protocols that we mentioned, MQTT and AMQP. Basically, there is different versions available, AMQP and MQTT 5.0. AMQP was released in 2008, and AMQP 1.0 was released in 2011. There are a number of differences between the capabilities of those protocols, so you can just have a look at the different requirements which are basically related to your deployment, or the different kinds of services that you will be implementing. Generally, the latest version is used in the Openstack deployments, whatever, if you regardless of whether you want to test it for your lab purposes or you want to offer any services. So there are a number of things that you can note in this comparison table. With this one, we just conclude this presentation. If you have any further questions regarding the messaging service in Openstack, how does it work, you can also leave a comment. Just another thing I want to mention, that we have covered the installation and configuration process of RabbitMQ in another video. The link for this one is already given in the description. If you like to configure the RabbitMQ for OpenStack with the particular specifications or the particular requirements, you can refer back to that video. And if there are any comments or feedback, you're always welcome. I hope this video was useful, and configure the services or to understand the processes, how the messaging services are basically used in the OpenStack to provision the different types of infrastructures like compute resources, the storage resources, the networking resources, or any evaluation the other services. Thank you very much.